Sometimes having the graph to look at allows you an opportunity to gauge what the zeros are that you're expecting to see. So you can see in this first example, I have a 0 at 3. That's my rational 0. It's an integer value, so I know that I'm dealing with a 0 at 3, 0. So there's one of my zeros. Okay, if it is asking me to find the zeros, it's asking me to find ordered pair. Okay, but my other ones here aren't necessarily going to be rational. Okay, and so we have our calculators to use for these. And so if I want to find my zeros in a polynomial function, I see here when I look at this graph, I have 3 zeros, correct? Each one has a multiplicity of 1. Okay, is that consistent with what I was expecting from my function? A degree of 3 means there's 3 zeros. So am I going to have any imaginary zeros on this? No, I have all my real zeros. Okay, so when I go into my calculator, what I can do is use my solve feature, so F2alg tab. And my zeros are just that. I'm going to take my function, I'm going to set it equal to 0. So 0 equals x cubed plus x squared minus 10x minus 6. And I'm going to solve for x. And when I do, I get my solutions. Notice up here I have my real 0 that I already knew, x is 3. But I also have these 2 irrational ones. Okay? When you're writing these, again, they come in conjugate pairs. And I'll talk about that in a second. But what that means is that these 2 irrational zeros are the same terms before and after the sign, just with a different sign between. So when I look at the 2 displays that they show me, the one that's easiest to interpret is this second one, right? The one with no parentheses. And when you write your irrational 0 as well as your imaginary 0, you're going to put the rational part first and then the irrational part second. So even though this is written as square root of 2 minus 2, I'm going to write the negative 2 first. Right? And then I'm going to write the square root of 2, so positive square root of 2. And so that's how I express this same thing, right? All I did is I moved the term negative 2 plus root 2. So this is one of my zeros. Right? And the conjugate pair is the same terms of opposite sign between. So it's the same term, negative 2 and root 2, but instead of a plus, it's a minus. Okay? And so this refers to this 0. Because this one is the plus, it's going to be the 0 that's further to the right. Okay, so that's my conjugate pair of zeros, and if I were to ask, or if it was asking me to enter these zeros, I'm just going to create this list. So my answer would be 3, 0, and then negative 2, and the order doesn't matter, but square root 2, 0, and then negative 2 plus root 2, 0. Right, what I want you to do is I want you to see if you can identify what all 4 zeros are for this equation in the example to the right, please. Again, when you can see the graph and you're able to identify that the number of times the graph crosses through the x-axis, if that corresponds to the zeros, then you know each one has a multiplicity of 1. Okay, and there's going to be no imaginary zeros. But if this only passed through the x-axis twice, but the power was a 4, then you would expect that you are going to have some imaginary zeros. So again, what I see here is I have these 2 integer values for 0, so I'm going to start with those. I can use my calculator regardless, and then I'm going to calculate where are my zeros. So I'm going to use the solve feature. set my equation equal to 0. So I get x to the 4th plus x cubed minus 20x squared minus 6x plus 24. I'm solving for x. Okay, so what I see right here is, here's my two integer values, 1 and 4, which I confirm what I saw. When I look at my irrational solutions, the ones with the radicals in them, the one that's easier to interpret is going to be this one. I'm going to write the real part first, so negative 3 and then a plus root 3. So negative 3 plus root 3 is my solution. And then my other 0 is going to be the same one, negative 3 and root 3, same terms, opposite sign between, so negative. The one with the plus is going to be to the right, the one with the negative is going to be to the left, and those would be my 3 zeros. And so if I continue to write them out here, you get your solutions written as exact answers.